So I have to ask, why am I spending my time giving this talk? And why are you spending your time listening to it? Well, it's because people, lots of people, are dying of cancer every day. We do not have a cure for cancer. We have treatments, we have procedures, but we don't have cures. If you look at the documentation of anybody's journey with cancer, going along with the medical industry, if you look at their insurance statements, their pharmaceutical reports, their doctor's reports, hospital reports, any paperwork you find, the words cure and heal do not occur. For the next 15 minutes or so, I'd like to challenge everything you think you know about cancer. Let's move on from the idea that cancer is a bunch of wild and crazy cells, out of control cells, abnormal cells, all of the above, that are going to take over your body and kill you unless we kill them first. The benign tumor is the correct model for understanding this condition, not a disease, it's a condition. The condition formerly known as cancer. I believe that the more accurate name for the condition formerly known as cancer is organomutagenesis. Organomutagenesis. Now, if you are a scientist, or if you have some basic biological background academically, I just have to tell you one thing and you could figure out the rest. So all I would have to say is that oncogeny recapitulates ontogeny, which recapitulates phylogeny. Run with that, and you will wind up at organomutagenesis. So the benign tumor is the correct model for understanding cancer rather than the malignant tumor. Why is that? Well, logically, if you wanted to understand a Mercedes, you wouldn't go perusing through a junkyard and putting all the car parts of a broken down Mercedes on a laboratory table to understand a Mercedes. Malignancy is a miscarriage of a pro-life process called organomutagenesis. What that means is cells in your body are adapting to an abnormal, unnatural, one or the other or both, environment in your body. And if you extrapolate the process that begins with change from a differentiated cell to a cancer cell, if you map out those changes, that is organomutagenesis. So we have cells in our body that are all differentiated. They start all with the same source, the zygote in the womb, and every division is a differential division. It's not like in bacteria or primitive organisms where every time they divide they create the same thing over and over again. But in your body you have differential division going on during embryogenesis. And those cells eventually become a mature differentiated cell with an identity as a skin cell, a liver cell, a blood cell. So every mature cell in your body is differentiated from the original zygote. I am saying that a tumor cell is a redifferentiation of a previously differentiated cell, meaning a liver cell, a blood cell, can redifferentiate. Now, how does it do that? I have an analogy. When you're ready to throw a baseball, the baseball is here and it's a certain distance from the pitcher's mound. But if you just throw it from here, it's going to fall short. If you just lunge it forward, it's going to fall short. However, if you go back a little bit and then throw it, you'll make it to the goal. It's not a smooth transition going directly from a liver cell to a new organ cell as it is to go back towards, take a few steps backwards towards being like a stem cell, really. So with this new version of a stem-ish cell, it can then move forward to adapt to this unnatural environment in a way of surviving and collaborating to create a new organ. The fact that there are benign tumors lets me know that it is possible, it's totally possible, for a differentiated cell to undifferentiate, redifferentiate into what is necessary to survive in an unnatural, abnormal environment inside your body. And that is what a tumor is, a benign tumor. Malignancy is a miscarriage of the attempt to create a new organ, to correct an unnatural body chemistry, blood chemistry, actually lymph chemistry. This lymph is in contact with your cells more than blood. So it's really abnormal lymph chemistry that we're talking about. So is it far-fetched to think that your body can create a new organ to correct a blood chemistry that has become unnatural or abnormal or both? Biological processes are reversible. This is true to some degree of all biological processes, or most biological processes. So let's look at the appendix as the reversal of organomutagenesis. It's organomutagenesis in reverse, where we used to have an organ or a gland in a certain location, and when the environment changed, it became unnecessary, and it remitted. Let me make an analogy to a pond that has fish and ducks and plants and nice water, etc. And you go to that pond regularly. And one day you go there and things are changing. There's a bunch of dead fish floating in the water. You look at fish that have strange growths on their bodies, or their shapes are abnormal. And so you call in an expert, say, something's wrong with my pond. And the expert says, oh, it's those abnormal fish are killing the good fish, and so let's kill those abnormal fish and everything will be fine. When all along the problem was that the Boy Scout camp on the other side of that pond got a new janitor who got some new chemicals that he's putting in the latrine that are seeping into the groundwater, going into the pond. And the dead fish are dying from the poison. The weird fish are adapting to the poison, to the new degraded environment for survival. It's all about survival. So the cure would be to figure out what is poisoning the pond, go and find it, neutralize it, eliminate it. That's the cure. Killing the mutant fish is not a cure, it's a treatment. How does a minuscule amount of toxin, carcinogenic toxin, in your food or water or air, how does that wind up causing a tumor? Well, that tiny little bit of toxin is declared irrelevant by environmentalists or industrialists. How so is it irrelevant? Well, it's irrelevant because if you take that little pinch of carcinogenic chemical and put it in a bathtub the size of your body, and you stir it up and take a sample, you can't even find a trace of that chemical, so it's insignificant. But your body is not a bathtub. It's more like a pinball machine, where something comes in and it gets bounced around and passed around and winds up in a certain hole somewhere. Okay, the path that this chemical took from your mouth or your nose or whatever, your skin, to an exit strategy is called a pathway. And along that pathway are molecules that have stereochemistry, like they have a shape, and the toxin has a shape. And somehow they have to converge and be compatible enough for that new chemical to form, and then it moves down the line, and maybe that hand releases it to another hand, etc., etc. But there are circumstances under which the stereochemistry in some location does not work with the toxin in a way that will allow it to continue down the pathway towards an exit strategy. So it gets stuck there, that little bit of toxic chemical. So what happens the next day? Same exact thing. It wasn't an accident. And so that same minuscule amount of chemical winds up in the same place. And so eventually there's enough toxin built up in that one place to begin harming, upsetting, or killing cells so that they will be induced to change, mutate, redifferentiate in order to survive. Organogenesis is a theory. I didn't read it in a book, nobody taught it to me in a classroom, okay? And I didn't find it in the laboratory, although bits and pieces of it came from my laboratory experience. Where does the word theory come from? Well, it comes from the Greek word theos, which means God. To some people, that's where theories come from. So what is the implication of organogenesis theory for inventing cures for cancer, or a cure for cancer? There'll probably be diverse. There'll probably be more than one way of curing cancer once people understand the theory of organogenesis rather than just killing cancer cells. You will find magazines after magazine, ad, or article on the internet about cancer prevention. You know, better diet, more exercise, cleaner air, all these things are preventative measures to avoid the condition commonly known as cancer, which is really organogenesis. And there is an adage that an ounce of prevention is worth a pound of cure, which makes the value of preventive measures a better option than waiting to need some kind of a cure. Well, I say that it is possible that part of the system of order to cure cancer is a pound of prevention. The very things you would do to prevent cancer, do them more abundantly, more regularly, more universally. A pound of prevention is the cure.